Welcome you all. Here I am, Ashamol, Assistant Professor from Emmanuel Arasar JJ College of Engineering in the Department of Computer Science and Engineering. Today I am going to introduce a topic about phases of compiler. So before entering into this topic, we can learn what is compiler. Compiler is nothing but it is a software program that translates the code written in a high level language into machine code. That is, a compiler is a program which takes one high level language as input and translate it into an equivalent another language. So that is compiler translates source program to target program. In another form, compilers bridge the gap between the high level language and machine hardware. And compiler requires to finding errors in syntax of program and compiler requires generating correct and efficient object code and finally runtime organization. So the next one is structure of compiler. The basic model of compiler can be represented in this picture. So what is this means? The compiler takes a source program as a high level language and converts it into low level language or a machine language. Next is properties of compiler. When a compiler is built, it should possess following properties. The first point is the compiler itself must be bug free. It must generate correct machine code. The generated machine code must run fast. The compiler must be portable, that is modular and supporting separate compilations. And the next one is it should give good diagnostics and error messages. The generated code must work well with the existing debuggers. And the last one is it must have consistent optimization. Uses of a compiler. A compiler makes the source code free from syntax and semantic errors. It generates the executable file of the source code and also it translates the source code from one language to another. This part is our topic, the phases of compiler. Compiler works in 6 phases from scanning the source code to generating an object code. The first one is lexical analysis, the second one is syntax analysis, third one is semantic analysis, fourth one is intermediate code generation, fifth one is code optimization, and finally the sixth one is code generation. This is the basic structure of phases of compiler. Here, the simple table also stores information about attributes of each identifier. The attributes of identifiers are usually its type, its scope, information about the storage allocated for it. And in compilation, each phase detects errors. These errors must be reported to error handler whose task is to handle the errors so that the compilation can proceed. Normally, the errors are reported in the form of messages. Structure of compiler. The process of converting the source code into machine code is called compilation. Compilation is basically divided into two parts. The first one is analysis part and the second one is synthesis part. Analysis part is the first part of a compilation. So this part is also known as front end. Analysis part is the first part of the compilation and it is also known as front end. Front end is machine independent. Here are the four analysis phases of the compilers. The first one is lexical analysis, next one is syntax analysis, and the next one is semantic analysis, and the last fourth one is intermediate code generation. The second part of the compilation is synthesis part. This is also known as backend. Synthesis part is the second part of the compilation and it is also known as backend. Backend is machine dependent. The remaining two more phases of the compiler is code optimization and code generation. Backend construct the target code from the syntax tree and from the information in the simple table. Here, code optimization offers efficiency of code generation with the least use of resources. Lexical analysis. Lexical analysis is the first phase of a compiler and it is also known as scanning. It is the initial part of reading and analyzing the program text. Text is read and divided into tokens, each of which corresponds to a symbol in the programming language. That is, it reads every character of the source code from left to right and characterized it into tokens called lexemes. Lexemes are such as keywords, operators, and identifiers. For, for example, if some assignment statement in our source code is total equal to count plus rate star 10, then in lexical analysis phase, this statement is broken up into series of tokens. That means uh, total is the identifier, equal to is the assignment symbol, count is the identifier, plus is the sign operator, and rate is the identifier, star is the multiplication sign, and number 10 is the constant number. The blank characters which are used in the programming statement are eliminated during the lexical analysis phase. Syntax analysis. Syntax analysis is also known as parsing. It takes a list of tokens produced by lexical analysis. It analyzes the source code for its syntax. Then these tokens are arranged in a tree-like structure which reflects program structure. Further, the compiler creates the syntax tree or parse tree that hierarchically represents the logical structure of the source code. The syntax analysis determines the structure of the source string by grouping the tokens together. This is the parse tree for the expression total equal to count plus rate star 10. In the statement total equal to count plus rate star 10, first of all, rate star 10 will be considered because in arithmetic expression, the multiplication operation should be performed before the addition. And then the addition operator will be considered. For building such type of syntax tree, the production rules are to be designed. And the third phase is semantic analysis. This phase of the compiler checks the meaning of the source code. It checks whether the program code follows a meaningful approach or not. It carries out type checking, which ensures that the value used in the source code. Type checking is a process of enforcing type constraints on values. So once the syntax is checked in the syntax analyzer phase, the next phase, that is the semantic analysis, determines the meaning of the source string. For example, thus these three phases are performing the task of analysis. After these phases, an intermediate code gets generated. Intermediate code generation. After all three analysis phases, that is, lexical analysis, syntax analysis, and semantic analysis, the compiler translates the parse tree into the intermediate code. This code is neither in a high level language nor a low level language. Any type of compiler can execute this intermediate code. The compiler finds it easy to convert this code into machine code. That is, this intermediate representation should have two important properties. The first one is it should be easy to proceed and it should be easy to translate in the target machine. The three address code consists of instructions, each of which has at the most three operands. For example, um, there are certain properties which should be possessed by the three address code. Uh, each three address instructions has at the most one operand in addition to the assignment. Next one is code optimization. This phase of the compiler deals with optimizing the intermediate code. That is, it aims to reduce process timing of any program and it eliminates any unwanted and useless lines from the intermediate code. It, its primary aim is to make the code execute faster with minimum resources such as CPU and memory. However, it is important to note that the original meaning of the source code should remain. Next one is code generation. This is the most important phase of the compiler, which accepts the sequence of code from the optimization phase and converts it into object code. Besides these phases, the two other important elements of the compiler are the simple table and error handling. Each compiler phase is associated with the symbol table and error handling. To support these phases of compiler, a symbol table is maintained. The task of symbol table is to store identifiers, variables used in the program, and this information is used in code generation. And the next one is error detection and handler. In compilation, each phase detects errors. These errors must be reported to error handler whose task is to handle the errors so that the compilation can proceed. Normally, the errors are reported in the form of messages. Advantages of a compiler. Some of the advantages of a compilers are efficiency, error checking, portability, and optimization. And some of the disadvantages of compilers are time consuming, difficulty in debugging, and platform specific code. So, by this, we conclude that the generation of machine readable target code from a high level source program, the process starts with the lexical analysis, which creates tokens, followed by syntax analysis to check grammar and semantic analysis to verify meaning. Intermediate code generation bridges these steps, leading to the synthesis part, code optimization for efficiency, and the final code generation into executable instructions. Throughout these phases, simple tables track information and error handling detects problems. This is all about the phases of compiler. Hope you this article was helpful to you in understanding the basis of the compiler. If you have any questions, share them in the comments below. Thank you.